All right, now we will be discussing within porosity logs the density porosity tool. One more time, I recap on what is porosity. First of all, it is denoted by the Greek letter phi. You will see that very often presented in logs. And in this picture, we have several images where the yellow part is solid rock, and porosity is the void space in that rock. So hopefully there will be hydrocarbons there. A good distinction is that sometimes that space is interconnected, which allows, if present, hydrocarbons to flow from the formation to surface and produce it. But there are some cases where those void spaces are not connected, and if they contain hydrocarbons, to produce those hydrocarbons, another job must be performed, like a fracturing job. But in general terms, there is porosity, the space in that rock that will contain hydrocarbons. And this is how it looks. Obviously, it will change the SAC model from one service company to the other. In fact, this diagram is from one service provider and this tool is from a different company, but they look in general very similar. Before going into the details, let me remind you that density porosity tools, they use a radioactive source, so additional safety measurements must be taken into account. Especially, or a specific one is to survey the area, and these are the instruments that are used to make those radioactivity surveys. So, how does the tool work? You can see that it has one caliper and it has a pad. In that pad, a radioactive source which emits gamma rays is installed. Those gamma rays will travel through the borehole and the formation from this area to the source to a short space detector and a long space detector. In these cases there are two, but there could be more. It depends on the company. Now, why running a density porosity tool? To get formation porosity that we will use to solve RGs and get water saturation. And these are another applications. Determining the volume of shale, identifying gasoil formation. Another comment that this tool is always run with a neutron porosity tool, like 99% of the cases. There are a few cases where neutron porosity tool is run alone, but in a log you will have usually a porosity curve from density and a porosity curve from neutron in a basic triple combo. So this tool will also help us estimating our hydrocarbon density, evaluating shaly sandstone, determination of overburden pressure, and evaluation of rock mechanical properties. A very useful tool. So to understand these measurements, we must consider two keywords: scatter gamma rays and absorb gamma rays. So once those gamma rays they leave the radioactive chemical source, they will start interacting with the atoms in the formation. So atoms, this area on this path. Some gamma rays will collide with those electrons and lose some energy. Some of them will collide with electrons and will be absorbed. Now, what is really important to know is that detectors are able to measure the energy level of those gamma rays. So the tool will be able to make a distinction of the reaction of this scatter and absorb gamma rays. So on high energy gamma rays, and what I mean by high energy is those gamma rays which energy levels are above 100 kilo electron volts, and by low energy is those gamma rays with energy lower than 100 kilo electron volts. But in this case, in scattering, these gamma rays provide info about electron density. I mean the number of electrons per cubic centimeter. And these interactions will be related to the bulk density and the porosity values. And these interactions will be related to the atomic number and will give us information about lithology, the photoelectric factor. This photoelectric factor. So we'll have a number associated with each type of lithology. And the photoelectric factor is associated its own by, it has a relationship with the average atomic number of that rock. So a distinction is made between the interaction of those gamma rays. Since our tool can measure the level of those gamma rays, we can have this to different values. The point here is that our gamma ray in this example, okay, you have your gamma ray is the yellow line, it makes a collision and it will continue to exist in the scattering reactions. In absorption, your gamma ray will interact with the inner electrons of an atom and will cease to exist. However, not 100% of these gamma rays are absorbed. They just have a low energy level, and the detectors will be able to measure this and will make that distinction. So when running a density porosity tool, all these corrections must be applied: the borehole diameter, the mode weight, the radius of curvature that is associated with the curvature of the pad, and when it's touching the formation, there is a difference in that curve. It's a geometrical factor that must be taken into account. And there will be positive correction and negative corrections. Usually when you're presented a porosity density curve, corrections are also shown, both positive and negative. Remember that a density tool is almost always run with a porosity tool, a neutron porosity tool. And when you're presented those values in a log, matrix must be assumed. In this case, as this example, a limestone matrix is assumed. You can see that we have 2.71 on this density porosity, which is the same as limestone, because this is the density of the formation. Another key point when reviewing a density porosity tool log is that you will often hear these terms. A stack response is this one, when both they read the same. A crossover is when the porosity from density is higher than the porosity of the neutron tool, and the opposite is separation. Well, this was just a review of our density porosity, and thank you very much for watching.